In the last video, we have found Vx as a function of time, x as a function of time. In this video, we are going to find Vy as a function of time, y as a function of time. In y direction, we have I'm ay equal minus mg minus bvy. M is the mass of the object. Minus mg is gravity force downward. And minus bvy is the air resistance force. And ay equal dvy dt. We now plug in ay into here, or dvy dt equal minus g minus b divided by m vy. We move dt to the right side, and then we move this term on the left side. So we have dvy minus g minus b divided by m vy equal dt. So dt we move to the right, and this term we move to the left. So now on the left side we have only vy here, vy here. On the right side we have t, time. And at this point we want to integral both sides. However, this is vy, and here in the bottom, here's vy and plus constant. So we use the following trick. Consider the derivative d minus g minus b divided by m vy dvy. This is a function of vy, and we make derivative dvy. So now this, the derivative of this term equal, the first term is constant, I have 0. The second term equal minus dvy d bracket b divided by m vy and this equal, the right equal minus b divided by m dvy dvy and equal minus b divided by m. So we just consider this is function of vy, and then we make derivative. So then the derivative of this one equal to minus b divided by m. Therefore, I have here d minus g minus b divided by m vy divided by minus b divided by m equal the right side equal dvy. And therefore I have dvy equal minus m divided by b d minus g minus b divided by m vy. Now, this one we plug in dvy into here. So we get the following. This equation is this. So this one we plug in here to here. We have minus m divided by b and d minus g minus b divided by m vy, and on the bottom minus g minus b divided by m vy. The right we have dt. Now this time this minus g minus b divided by m times vy is the same as the bottom minus g minus b divided by m times vy. Then we integral both sides. We integrate both sides. We have this is constant. We take it out. Minus m divided by b, and integral here 1 minus g minus b divided by m vy and d minus g minus b m vy equal dt. Now, since this whole term equal to this term the same, they are identical. Therefore, the left side, when I integral m b, so this integral equal log ln minus g b m vy equal the right side equal t and plus an integral constant c double prime. If I move this coefficient to the right side, I have here ln minus g minus b I'm vy equal minus b I'm t plus c double prime. I just move this to the right side, and I write down, reorganize minus g minus b I'm vy equal minus b divided by m time t plus this constant time c double prime equal a new constant I call it triple prime. Therefore, I have minus g minus b divided by m vy equal e to the minus b I'm t plus triple prime. If I write down further, I have here minus g minus b divided by m vy equal e to the power the sum. Here I have e to the minus b I'm t and time e to the c triple prime. Now I want to determine the integral constant. Now we determine integral constant. Constant. We use the initial condition. At time t equals 0, we have vy equal to vy 0 and equal v0 sine theta. So therefore, we plug in t equals 0 on here, and vy is here, we plug in here, vy is here, t equals 0 here, we have minus g minus b I'm v0 sine theta e to the power minus b divided by m time t I set to 0 and time e to the power c triple prime. And e to the power 0 is 1, so I have here's minus g minus b divided by m v0 sine theta equal to e to the c triple prime. Therefore, I got determined the integral constant e to the power c triple prime. Then I substitute this term to here. Now we have the equation for the integral constant. Now we need plug in this equation here into here. Then we obtain minus g minus b divided by m vy equal e to the minus b divided by m time t time e to the power c triple prime. This is equal minus g b divided by m v0 sine theta. And then we write Vy from this equation. We write Vy as minus g minus e to the power minus b divided by m t minus g minus b divided by m v0 sine theta. And time m divided by b. And I write down further equal minus m b g minus m b bracket minus g minus b m v0 sine theta and e to the minus b m t. And I can further simplify as Vy equal minus m b g plus m b g plus V0 sine theta e to the minus b I'm t. Now this is equation we want to find. This Vy as function of time. Now, we want to find physical meaning. At time equal to 0, Vy equal minus I'm b g plus bracket I'm b g plus V0 sine theta times e to the 0 is 1 times 1. So this term gave me V0 sine theta. So this is just the initial condition for the velocity in the y direction. As time approaches infinite, Vy approaches minus I'm divided by b g plus I'm b g plus V0 sine theta time e to the negative infinite. Okay, I write down here e to the power negative b I'm times infinite. So this whole term e to the minus negative infinite equal to 0. So this one equal minus I'm b g plus the whole term I'm bg plus V0 sine theta time 0. So the answer is minus I'm b g. As time approaches infinite, Vy approaches minus I'm b times g. This is called terminal speed. In this case, from the equation of motion in y direction, I'm ay equal to minus mg minus b times Vy. When time approaches infinite, the right term equal to minus mg minus b times Vy. Vy equal the terminal speed. So minus m divided by b times g. Then we simplify the right term, we get minus mg plus mg equal to 0, i.e. no net force in y direction as time approaches infinite, and the speed is constant in y direction, which is minus m divided by b times g. The next objective is find y as function of time. Now we need to find y as a function of time t. We know that Vy is defined as dy dt. Now we plug in here into here. So we have dy dt equal minus m divided by b times g plus m divided by b times g plus v0 sine theta times e to the power b divided by m t. And we move dt to the right. So I have dy equal minus m divided by b times g plus m divided by b times g plus v0 sine theta e to the power minus b divided by m t and bracket dt. So we move dt to the right. Now dt times here and dt times here, I got two terms. So I have two terms. So minus m b g dt plus m b g plus v0 sine theta times e to the power minus b divided by m t and dt. Now I integral both sides. I integral both sides here. dy on the left side, integral dy equal the first term minus m b g dt plus integral m b g plus v0 sine theta bracket e to the power minus b m t and dt. I have integral a constant, so I put the integral constant on the left side. So I have here integral dy, I write down here y plus c 4 prime equal the right side. I have here's coefficient. So here's minus m b g and time. Here's coefficient, just a number, I take it out. Then integral dt, I get t. Then plus here. This term is constant, I take it out. Here's m b g plus v0 sine theta bracket. Now integral this term. To integral this term, I time minus 1 m b I time this factor, then integral here e to the power minus b m t. Now d minus b m t. So what I did is here's dt is not the same as exponential part. So the exponential part has minus b divided by m. So here I make sure it has minus b divided by m and t. So now this term and this term are the same. But I put minus sign, I had to times minus sign. So minus minus get positive. Now I have here m, bottom m cancelled, b cancelled. So the next step is equal minus m b gt plus bracket here's m b g plus v0 sine theta minus m divided by b, and this integral I have e to the power minus b divided by m times t. And equal minus m b g t and minus m square b square and g plus m b with 0 sin theta and e to the minus b m t. Now the next task is, now we determine the integral constant C 4 primes. So we use the initial condition as at t equal to 0, we have y equal to 0. So therefore, here 0 plus c 1 2 3 4 prime equal minus m b g time t equals 0 at time 0 minus m square b square g plus m b with 0 sin theta e to the power minus b m times 0. So we get e to the 0 is 1 and this term 0. So we find the integral constant c 4 primes equal minus m square divided by b square g plus m b with 0 sin theta. So we get integral constant. Now we plug in this integral constant into here, we get expression for y. So it's here. So y plus integral constant, y plus integral constant equal this expression. Then we find also the integral constant is here, so we plug in here to here. So we have here y minus m square b square g plus m divided by b v0 sine theta equal minus m divided by b gt, that minus m square b square g plus m divided by b v0 sine theta, and time e to the minus b m t. We can move this to the right side, so we have y equal minus m b gt plus m square b square g plus m b v0 sine theta bracket minus m square b square g plus m b v0 sine theta e to the power minus b m t. We can also simplify the above equation as y equal minus m divided by b gt plus m square b square g plus m b v0 sine theta 1 minus e to the power minus b I'm t. So this is the result for y as function of time. So we find the physical meaning as follows. At t equal to 0, so y, this at time I plug in t equals 0 here. This equation, if I plug time equal to 0 here, so this term 0. So y equal minus I'm b g times 0 plus second term I'm square b square g plus I'm divided by b with 0 sine theta 1 minus e to the minus b I plug in 0 here, this. So the first term, this term 0, the second term I'm square b square g plus I'm divided by b with 0 sine theta 1 minus e to the 0 is 1. So I got 0. So this is the initial condition for y equal to 0. As t approaches infinite, y equal to minus I'm divided by b times g times t plus I'm square divided by b square times g plus I'm divided by b times v0 times sine theta, and this term equal 1 minus e to the power minus b divided by m times infinite bracket. So this term equal to 0. So, and this term is v terminal, the terminal speed. Terminal speed times t plus bracket m squared divided by b squared times g plus m divided by b times v0 times sine theta bracket, and this term equal to 1. So the final answer is, as time approaches infinite, y approaches v terminal times t plus m squared divided by b squared times g plus m divided by b times v0 times sine theta, and the v terminal is defined as minus m divided by b times g.